In this tutorial, we will show how to modify an imported step sheet metal model using ZW3D Direct edit tools and convert it into a native sheet metal part. Let's begin. From the Quick Primer ribbon toolbar, we select Import. We browse to the electrical enclosure step file and click Import. When the step file import dialog appears, we click OK. The imported sheet metal model opens in ZW3D. From the left panel, we select the isometric view, then return to the Feature History Tree tab. From the Inquire ribbon toolbar, we select Measure. We calculate the distance between the embossed surface and the base plate. The distance measured from the center of the embossed circle to the base plate is 25 millimeters. We click Unpick All and measure again. This time we measure from the center of the embossed surface to the XY plane. The distance is 71 millimeters. After clicking Unpick All once again, we measure the second emboss relative to the base plate. The distance is also 25 millimeters. We then exit the Measure command. To modify the emboss position from the Direct Edit toolbar, we select Dimension Move Face. In the Motion group, we begin by selecting the faces of the two embosses to define the movement references. We then rotate the model and continue selecting the remaining faces. It is important to leave one face unselected, as it will be used later as a reference face. For the anchor point, we define the center point of the embossed circle as the reference location. Under Measure Direction, we select the direction line. Then, in the Motion Face option, we select the previously unselected reference face. As the fixed stationary face, we select the base plate face, enter a distance of 20 millimeters, and validate the operation. We repeat the same procedure for the remaining two embosses, following the same steps we just completed. This way, we make sure each emboss is adjusted in the same manner, using the same selections and settings, so everything stays consistent across the model. These modifications can be reviewed using the roll bar animation in the feature tree, allowing us to compare the model before and after the edit. Next, we switch to the Modify Fillets command to continue editing the model. We select the four outer embossed surfaces. As we can see, ZW3D automatically detects the existing fillet radius of 4 millimeters. We change the radius to 3 millimeters, validate the operation, and click Update. Again, we use the roll bar animation in the feature tree to compare the model before and after the modification. After that, we continue with the Direct Edit Pattern command. Here we select the louver geometry, making sure all associated faces are included. We then choose the pattern direction, set the spacing to 10 millimeters, and specify 3 instances. As we edit the model, changes update in real time, allowing instant visual feedback and dynamic preview. We then select the Simplify command. The Simplify tool is used to quickly clean up imported models by removing unnecessary features. We select the geometry we want to remove and validate the operation. ZW3D automatically heals and closes the adjacent surfaces. Once again, we use the roll bar animation in the feature tree to review the model before and after the edit. Lastly, we continue with the Direct Edit Mirror command. In this step, we select the geometry or faces we want to mirror, making sure the correct regions are included for the operation, then choose the Y-Z plane of the coordinate system as the mirror plane and validate the operation. Our model now meets the required design changes, and we are ready to convert it into a sheet metal part. From the Sheet Metal ribbon toolbar, we select Convert to Sheet Metal. First, we select the stationary face. We then click Collect All Bends. In the settings, we enable Keep Punch Shape and validate the operation. As we can see in the feature history tree, the imported step model has now been converted into a native sheet metal part. We select Flat Solid in the tree and double-click Flatten. We change the offset value to 50 millimeters and set the Z direction to -1. We hide the solid body and verify the flattened result. Finally, we enable Flat Pattern. As we can see, the completed flat pattern is now displayed and clearly shows all bend directions. We then unhide the solid body. Thank you for watching.